So today we're going to start the actual trig functions. So what we're going to look at is I'm going to try to talk a little louder here. We're going to look at something called the unit circle. Now most people, when they think of trig, they think of triangles, because that's what we end up applying it to most of the time. But in reality, trigonometry comes from a circle. Pretend that looks like a circle. We defined a lot of features of a circle in the last unit, and those are all going to be very important to us now in our trig. First thing we defined, of course, a diameter, and this horizontal diameter we defined to be what? Do you remember the special name we had for it? It was a reference diameter. We also talked about how navigation was used to originally define angles and stuff like that. And in navigation, the east direction over here was 0 degrees, and it went around counterclockwise around the compass rose for our navigational directions. So like straight north was 90 degrees, and straight to the west was 180, and so on. Now I'm also going to put in a vertical diameter here to make kind of like a crosshairs in a scope. That's because originally all this dealt with the east-west and the north-south concepts, directions. So an angle, now the reason this is called the unit circle, by the way, is because it's defined to have a radius of 1 unit. So from the center of that out to the edge of the circle is 1 unit in length. So an angle is defined to go from the center of the circle out to the edge. This is the angle right there. Now what we're going to do is we're going to use a variable to represent that angle. And the variable we're going to use looks like this. That's the Greek letter theta. It's for some reason, we use x, y, z for variables representing lengths. When we're representing angles, we usually tend to use the Greek alphabet. Also, another standard notation, if you're not using the Greek alphabet, lengths are with small letters, small x, small y, so on. Variables are with capital letters. So anyway, based on that angle theta, its sine, remember we talked about the sine being the distance from any point on the circle to its reference diameter? So that angle defines this point on the unit circle. The length from that point down to the reference diameter is the sine of that angle. One of the other features of the circle we talked about was something called a tangent. A tangent, remember, touches the circle but doesn't penetrate it. A tangent was always perpendicular, formed a right angle with a radius to that point of tangency. When we're talking about trigonometry in the unit circle, tangents are always drawn tangent at the reference diameter. So here's the reference diameter. It's going to be tangent here. It's going to extend up this way. How far does it extend up? Well, until it is intersected by this line coming out of that angle. So that purple length there, that right there, is the tangent of that angle. Now the third main trig function usually takes people by surprise. The third main trig function is not cosine. The third main trig function is actually the secant. Remember, the secant cut through the circle. So if we extend that line out that forms the angle out so it cuts through the circle, and we run it until it intersects the tangent, that is the secant. That length is the secant of that angle. And if you were to actually draw this out to scale and mark an angle on there, measure these out, the lengths of those pieces would actually be the value of that trig function. Now you'll notice, remember the radius is how long? 1. So the sine is always going to be less than 1. Because the greatest the sine could be is if the angle is 90 degrees here, that's still only a radius of 1. So the sine will always be 1 or less. Tangent can be really small, it could be 0, or it could be really huge. So the tangent can be any value. The secant, however, is always going to go outside the circle. So it has to be the radius plus some. So the secant must always be greater than 1, or 1 or more, I should say. So some of you are probably thinking, what about this thing we heard about called the cosine? Why did I not talk about the cosine at all yet? Well, the cosine is actually a prefix. The prefix co means of the complement. What's a complement? Boy, you sure look nice today. No, mathematically speaking, a complement is what? There you go. Adds to 90 degrees. So, if we look back at our picture up here, where's the complement of theta going to be? This angle right here is its complement, isn't it? So when we do the cosine, we're looking at its complementary angle. That red mark right here is the angle that's complementary to theta. So its sine would be this distance right here. That is the cosine. Now, most often what we do is, since these are all right angles here, we bring that distance down here and we define this length to be the cosine of theta. And then, of course, the cotangent and the cosecant would all be up here on the complementary angle. So what this means, for example, it's a sine, and we're going to abbreviate sin, S-I-N, of 30 degrees is 0.5. If I tell you that cosine, abbreviated COS, of 60 degrees must be, if the sine of 30 is 0.5, the cosine of 60, remember, it's asking me the sine of the complement. What is the complement of 60? 30 degrees. The cosine of 60 has to equal the sine of 30. 0.5. Make sense? No? My voice isn't going to make it today, so I'm going to cut it off here. But it's a little introduction for us tomorrow. Hopefully I can talk more. And we'll pull out the calculator and start punching in numbers, and I'll demonstrate this a little more. But the whole idea of the cosine, cosecant, cotangent. Now, the cosecant and cotangent we're not going to use a lot. We'll do some calculator exercises to figure out, get the values of them, and after that we're going to forget they exist. Because we use, the buttons on your calculator are sine, cosine, and tangent. So those are the ones we're going to use for all of our problem solving. But all those cofunctions, cosine, cosecant, cotangent, the cosecant of 30, or let's pick a different number. The cosecant of 21 degrees has to equal the secant of, what's the complement of 21? 69. That's it. Yeah. So let's stick to the sine and cosine. If you want to punch them in your calculator, you can. What's the complement of 21? 90 minus 21. So, punch in your calculator. What is the sine of 53 degrees? 766. Okay.
Wait, is it 53 degrees?
53.
7,986.
Cosine of 37 degrees. Yeah, why is it the same? Because they're complements. If the two angles are complements, the sine of one is going to equal the cosine of the other. Because the cosine of 37 is literally asking, what is the sine of the complement of 37? And the complement of 37 is the 53. Okay, we're going to cut it off here. I'm not going to give you guys any homework today.
Yay.